user-defined classes and objects. So today's objective is to understand how Python implements classes and objects. And the last time we did iterators, which is kind of a completely different concept, but it's related because iterators can be implemented in a class, right? Your class could implement an iter method and a next method. So you could implement iterators in a class, but classes and objects are very generic, kind of object-oriented programming, so it doesn't have to do the iterators. We'll basically talk about class and object, which is, I think I got this right, class object H and class object C. I think that's the right, sorry, let me go, yeah, class object.h, class.object.c. It's just those things. And thing is due on Friday, and that's pretty much the agenda. Okay, so to dive right in, we're actually just going to go use the counter example that we're going to have on the assignment, just so you're familiar with it. The assignment, you're going to be tracing through the code and the iterator part. Today, we're actually going to trace through the building the class part. So if you actually look at the, they all have to do with each other. If you look at the assignment itself on the very bottom, it will show you to scroll. It will show you, here's this counter class, and then you create a counter here, and then we do a for loop and iterate through it. So today we're actually just going to go this part so you understand what a counter class is. And then for the assignment, you're going to do this part, the for loop, and what happens when you call an iterator on it. Okay, so I broke this code out into code. I guess if you really want to follow along, I guess you could copy the code from the assignment. I guess you can just copy this. If you really, I think if you want to follow along, I think that's a good idea. So whoever has a laptop wants to, you go to the assignment page, copy this, and I'll paste it myself too, just so we can be on the same page. So edit, I call it count.py. My file name is called count.py, just to keep it simple. Should be 16 lines with the right spaces and stuff. I just pasted in count.py, so whoever wants to do that can just paste that in now while I get some other stuff set up. So again, it's just from the assignment page, and just don't worry about the for loop.
Hey, Mom, sorry, I was in a job
Yeah, meeting outside.
I got it.
All right. So while people are pasting it, I'll explain this briefly. So the syntax for class in Python is pen up. How many of you have done like some kind of object-oriented programming, like classes and objects and stuff? Okay, so most people have done something with classes, like in Java or C++. So the principles are pretty much the same, but the syntax looks different. So let's use the red pen. Use the red pen. So you all should be, whoever has a laptop and follow along can just copy all this stuff in. So remember in Python, indentation denotes kind of block scope, so you have to indent in for everything. So there's no braces, so there's only indentations. So the way to read this is a class is defined by the class keyword, and you put the name of the class, and then a colon. You could put other stuff in here in parentheses, like super classes, like if you're inheriting from something, but the simplest way to make a class is just to say class name. Usually it's capitalized as a convention, just like in Java, and then colon. So class it's sort of like defining a function, but it's defining a class, and then you go indent. So everything inside here is inside the class definition. So it's like Java. If you have just think of indent as braces, right? If you're familiar with Java or C++, every indentation is a set of braces. So then you have, inside a class, you actually have a bunch of methods, because what do classes have? Classes have a bunch of methods or functions inside of them that you can call on the class. So there's a bunch of def statements here. Each def statement is a method, followed by a name and parameters and colon. So these are just standard function-like definitions, except they're called methods because they're inside a class. And notice how there's a special underscore init function or method, and that's called a constructor. So in Java, you would call this a constructor, or C++. And usually in Java or C++, you actually call the constructor the same name as the class itself, right? But in Python, it's just called underscore init, just as a convention. All these other things are regular methods. All these methods take a self argument as the first argument. Notice that? And it's because in Python, you actually explicitly have to write self. I don't think you have to call it self, but people just call it self as a convention. So in Java, you would have something like this as the pointer. C++ does have this also in C++. People use C++.
It's been a while.
Yeah, I don't remember. Actually, you don't, right? I don't know what they call it in C++, but any method, you need to actually refer to the object itself. Right? Is it this in C++?
Yeah.
Okay. It says it's a reserved word, right? It's probably some reserved keyword. Okay. So in Python, it's just called self. I'm pretty sure you can name this whatever you want. It's just the first parameter to any method must be the thing that the object you're calling it on. So people call it self just to make it simpler. So the way to read this constructor, usually construction in Python, the way to read it is you always have a self as the first one. Now these are the parameters you take when you construct your object. So this constructor takes two parameters. It says there's a self here, but don't count the self. Everything inside the class, there's this implicit self, so you don't want to count that. So it says that in order to make a new counter, you have to pass in two things, a low and a high. And what does it actually do? It actually takes the value of low and sets it to self.current, and takes the value of high and sets it to self.high. Self, remember, is the instance, is the instance of the object that you are just creating. Dot means we're going to access a field in the instance, and current and high are just field, and we're just going to initialize them to low and high, respectively. So the way to actually use this is down here, right? That you're calling counter. It looks like you're making a function call, but because this counter is a class name, is a name of a class, by calling it like a function, you're actually running the constructor, the init method. And you pass two things, 5 and 7, which go in low and high respectively. And there's no self. You don't pass in self, because self is the thing that you're creating right now. And when it's done creating it, the special constructor method, the init method, will return self to C. Will actually return the thing that's created to C. So now C should actually point to some instance. Instance is a specific instance of a class. Instance of counter. And C now has two fields inside. C has, you could say, current and high. And current is what, 5? High is 7. Does that make sense? So when you make C, C is some instance of counter, and then has two fields in it, a current, which is 5, and a high, which is 7. And then you can go inside of C. You can say C.current, C.high, just to access it, like that. So let me actually just run this code in the visualizer just to solidify that. So a lot of how these lessons work is we'll just start with the Python first, and then we'll actually go inside the interpreter. So let's go to this code right here. We'll copy it to Python Tutor Visualizer, and we'll paste it in, and we will run it. Okay, so remember, everything is done at runtime in Python. So when you first start writing this code, there is no class, there's no nothing. There's just an arrow saying we're about to run this line. So as soon as we execute this line, something exists. So counter is now a global variable, and it points to a counter class. And the counter class has three things. It has init, iter, and next. Each of them are just functions. So it's just init, iter, and next. So that first line running it just defined a class, which is just some thing in memory. And it defined a class, and it pointed counter to it. So you can access it using the name counter. So now what you do, the second line, when you run the second line, it does C equals counter 5.7. So it actually will jump inside the init function. Notice how the execution jumps inside there. And then it'll actually run the init function, because you called counter on 5 and 7. By calling a class as a function, you're actually calling the init function. It's just, we'll see how that's hooked up. So we'll run it, and then this goes self.current. So notice how inside the init function, we actually pass it. This is init, which is a function, right? we pass in low and high, which is 5 and 7, and then it creates a self for us right now, counter instance. So the self is empty right now, and we step through it. Notice how self actually fills up, right? Self.current fills up with the value from low, and self.high fills in from 7. So now we actually have a self thing, which is an instance of counter, right? So there's counter, which is the class, which is sort of like a template for how you create things, and there's an instance of counter, which is what we call as an object. So it's sort of confusing in Python because everything's an object, but we call this like an object in the Java way, and we call this a class. So a class is a template to create a bunch of objects. So you can imagine with one class we create like 3 counter objects or whatever. And once it's created, it just returns it to C. It just returns the instance it's created and binds it to C, and then there we have it. All right. So let me just give you a little bigger example, just to kind of drive this point home. Is we'll say D equals counter 10, 15. So when we run, it's the same thing. I'll just show you the very end. So the very end, there's still only one counter class. The capital counter points to the counter class. This is like kind of a template, right? And then we call this init in this class to instantiate 2 instances of it. One is 5, 7, one is 10, 15. One is bound to C, one is bound to D. So this is standard object-oriented programming. You have a class, and then you have a bunch of instances you create. And the nice thing about this is that every instance is independent of each other, right? That you can mess with C, and D doesn't get interrupted, and mess with D, and so forth. So there's all sorts of fancy stuff you can imagine doing with classes, like static methods and fields and whatever. But the basic thing with a class is it's just a way for you to create objects from them. So notice how, one thing is the class here only has 3 things. Init, iter, next, which is init, iter, next. But every instance has current and high inside of there because it's this self current and self high right there. Right? So the class doesn't have current and high. The class only has these methods for you to create instances with it. Cool. So what does this code actually look like? So any questions on this so far? On what Python classes and objects look like from the Python level? So just knowing this, you should be able to create a basic object-oriented program in Python, like a game or a web app that have objects representing players or weapons or levels or whatever, and you can hook them together. Yep.
So the current, like the third line, there's a self.current.
Yes, this one.
Like usually in C, you will have some private variables that
Yeah.
there's a current, right? But so for Python, there isn't a need for that.
Yeah, so there's no namespace. There's no private protected whatever in Python. Protected public. Yeah. So first of all, there's no private protected public.
But there isn't. So the current doesn't even exist, right? So how?
Current does not exist. That's right. There's no
There's no definitions.
There's no slot. That's right. You're right. So I think your point you're bringing up, maybe I'm reading your mind or not, is that in C++ or Java, there's a compiler, right? That actually that's actually a really important point. Thank you for reading my mind, or not really. But so in C++ or Java, you actually have a class declaration that says every object has to have a current slot.
Right.
And a
You used to have a slot, right?
high slot or whatever slot, right?
Yeah, you have.
And it's because in C++ you want to actually create an object with a certain size. It's like a struct in C, right? The class in C++, every instance needs to have a certain size, and everything needs to be in a known place. And that's very nice for C++ or Java because it's very efficient, right? Because you can actually just index and access these fields directly. So when you want to get a field, you actually just say, get me the address and offset it by 2 or whatever. So there's a template. So in Python, you actually don't have that. So that's actually a big difference. So Python, Ruby, I guess Perl, basically these dynamic languages implement object-oriented programming not as a struct like in C with fixed location, but as a dictionary. So really, yourself just is a dictionary that that has self.current, self.next, or whatever, high or whatever. So these are actually dynamic modifiable. So this is actually a really good point you brought up, because now what I can do is, let's just eliminate the second one because we don't care about it. So now what I can do is I can just say C dot, low equals -5 or something, I can just add a new field on the fly. Like nobody prevents me from doing that. So if you see this, or if you see that, I'm on this last line here, c.low equals -5. I just set forward, I just create a new thing, and it's just a new low equals -5's in there. It just pops in there. So all it is a dictionary. And imagine inside it's just a dictionary having keys to values. So this actually has pretty profound implications because it means you can add and subtract fields from every object at runtime. So you can add methods to this at runtime. So that's how you do things like mix-ins and other sorts of ways we can mash up different objects. Whereas in C++ or Java, you have to pre-declare. You can't just like sneak in an extra field, right? Because the object size would change. So the advantage of the C++ Java way is that it's more efficient, right? Disadvantage is that it's less flexible because you can't add stuff on the fly. So you can imagine actually subclassing built-in types like strings or other stuff on the fly by just adding methods to them or adding properties to them. So JavaScript, you can do this, right? So if anyone who programmed JavaScript, you can just say anything dot anything. And the problem with that is if you misspell it, you're actually creating a new field. Right? So if you're in JavaScript, you're actually misspelling stuff. It thinks you're creating some new field and assigning to it. Just like here too. I mean, c.low is I just created a new thing. It just appeared. So that's actually a pretty fundamental difference. So there is no pre-declaration beforehand. Good point. At the same time, I mean, this is even more meta. We don't want to go into this class, but that all of this classes is just executing code. You can imagine actually building, they call this meta classes in Python. You can imagine dynamically building up classes that are different based on some condition. Like if the user entered, you can imagine this. Conceivably, you can do this. So if, let's say you prompt the user for like, I don't know, what kind of, I don't have a good example, like what kind of car they like or whatever. And then based on that, you actually generate a car class based on what kinds of car they like, SUVs or cars or whatever, with different constructors and everything. I don't know why you would do that, but you could do that. Because I mean, the idea here is that everything in Python is just code that's run at runtime, and you can mix and match them and so forth. So there's this concept called meta classes in Python that you can look into. It's not really part of this class, but you can do weird things with that. Okay, so for this class, we're just going to stay with standard kind of vanilla classes you would see in like a Java or a C++ class. Okay, so we'll dive right into the code. So let's actually disassemble it first. So we'll say Python dis count.py. If you notice, if you disassemble it, there's not much actually going on that's exciting. The first line loads some counter. It just loads a string called counter. Then it loads some empty tuple, just empty thing, and then it loads a bunch of code, which is basically the code inside the class. And then it makes all this into a function, calls it, and then builds the class. So what this actually does is it actually runs the code inside the class, and then it calls this build class thing. So like make a class object, and then just stores it in the name counter. And the second one loads counter, loads the parameters 5 and 7. Remember, this is counter 5, 7. Calls the function and then stores it in C. The C equals counter 5, 7. So the interesting thing here is, let me remind you of the code here. Remember, focus on this line 16 here. If you just look at the bytecode, you don't know this is instantiating an object or from a class, right? All it says is load a name, counter, load some parameters, 5, 7, call function, store name, and then we're done. Because if you actually stare at this, the compiler or the interpreter is not very smart. If you stare at it here, this line itself, actually, let's go back to it. This line is just C equals counter 5, 7. Like this could be a function call for all you know, right? It's just a function call. It looks like a function call. But it so happens that if this function is a class, that the interpreter has to do something with it to call the init. So we should see how that actually happens. But the first part just builds the class. So it's so let's look at this build class opcode, what it actually does. So we'll gloss over a lot of the details because it's sort of tedious. But if we go to Python, so let's go to cval again, our same function we're always in. Let's look up build underscore class. which is the 1936. That's the line number. So what does this build class do? If we look at the documentation, Python dis, we'll just look at build class, and then she says create a new class object. So it has the methods dictionary, it has the tuple of names, the base classes, and the class name. So there's three things on the stack. The top things, the methods, all the methods inside, all the base classes, and the class. Base classes are like your super classes if you're inheriting. Most of the time it'll be empty. So in our code, go back to our code. Oh, sorry, the bytecode. I don't have another terminal open, sorry. The bytecode count up UI. If you notice, roughly, there's the name of the class, the base classes, and then all this stuff will end up making a methods dictionary. So this this load make function call function, it'll actually end up making a dictionary of the methods of the class. So then when we call build class, we have the methods, we have the super classes, which is nothing, and then we have the name counter. So that's enough. And imagine, like, if you're an interpreter, how would you make a new class? You need three kinds of information, right? You essentially need the name. You need the base classes, who you inherit from, which is nobody, and then you need all the methods. You need to know what all the methods are, both what the name is and what the code is. So with all that information, like, that's everything in the class. Right? I mean, there's no more stuff in here. It's just that's everything that is in our class. And if we look at this visualization here, our counter class, unsurprisingly, looks like a dictionary of methods, and it has a name, and that doesn't have any super classes. So that's basically it. So the build class just creates a thing that encapsulates all of that. And confusingly enough, that thing is an object, because everything in Python is an object, and that thing is called a class object, which is a very confusing name. So if we look at the build class opcode, it's actually pretty straightforward. It just takes the top thing, the second thing, the third thing from the stack. It adjusts the stack -2, so it pops those two off. Then it just calls build class on the three of them. Then it sets the top thing to X, which is the result of the class, and then it kills the rest of the things. Takes three things, which is name, methods dictionary, and base classes. Calls build class. Okay, so what's build class? So let's just search, goes into it. Unsurprisingly, there's a methods dictionary object, a base, which is a tuple of bases, and a name. And see, it does a bunch of boring stuff to check the types. Let's see. So this is where these meta classes come in. If you actually really want to go into class creation detail, it's complicated. We'll gloss over all that. What it does is it actually calls a function on the meta class of the class, and with the name basis methods, and this result. Oh, this is an error, so let's not care about the error, and it just returns the result. So it's like, well, that seems really indirect. But so the kind of magic that we'll gloss over is that there's this thing called a meta class, which is a function you call with a bunch of stuff, names, or the name, the bases, and the methods. And after you call this meta class weird function, it will actually give you a class itself back. So you can think of a meta class as a function that I don't visualize it here, but when you go like this, it actually, to create this thing, we had to call a function, and that function is called the meta class. All that function does is take the name and then take these methods and bind them to a dictionary and put them all together in one big glob. So every object in Python has a default meta class, which is what you'll use, but you can imagine writing your own meta class. Maybe that's actually so for those of you who are actually curious about it, doing a project related to that could be cool. That's an idea, because that's a pretty advanced Python concept that you could explore for your project. So Python meta class. That could be actually really cool to write up. What is a meta class in Python? No one actually knows. It's so confusing. What do you use them for? The meta class is a class of a class. Like the class, how a class defines how instance behaves, the meta class defines how a class behaves. It's very confusing. Yeah, this is all super confusing. But if you do a project on meta classes, you just have to write Python code. You don't have to dig into the interpreter. So it's pretty neat because you actually get to write like really weird Python code that affects how classes get created. So here's like here's an example of meta class. Actually, I actually used it once in my life for something useful. So one of the things you might want to do with classes is it would be really useful for debugging, right? Like imagine if you wrote a bunch of I don't have a, this is it's a small class, but imagine like at the end of every class, you want at the end of every method, you want to print out the field self.current, self.high, whatever. Right? You want to print that out so you can debug, and then at the end of everything, you want to print it, because this is what people usually do for debugging, right? Like if you really there's a return here, whatever, right? You're like, I don't know if my thing works. I'm just gonna put a bunch of return or print it in the beginning of the function. So put it in the beginning of the function, because whenever I call the function, I want to debug the output and say, oh, am I still the same? So conceptually, I want to inject a print statement in the beginning of every method in my class. But imagine I had a big class like of people or games or whatever. It'd be pretty annoying to put a print function in the beginning of every method. Or maybe I took over someone else's method, someone else's class, right? Like my partner made one, or I grabbed one from the internet. I want to inject all that stuff in. Seems hard to do. It's very tedious to do manually. But one way there's a few ways to do it in Python. One way you can do it is imagine making a meta class so that when someone actually executes the code, this is all screwed up now. But when someone executes this code, so this actually could be a cool project idea to explore meta classes, because it's kind of advanced and weird enough that it'll make for a substantive project. So when you go like this, when you execute, magic happens. It calls the default meta class. It creates all these functions and methods, and we're good. You can imagine writing a meta class. I think I did this once upon a time. I don't remember how I did this because it's weird. Is that instead of using the default meta class, bam, to create a class, you write a weird custom one. So when this executes, these methods are actually modified to inject a print line in front of all of them or something. So then you can actually get that behavior of debugging for free. And that will work on any class you create. You get a debugging behavior. Or you can add assertions to check for certain properties. Or it's thinking about like, or you can imagine injecting an extra parameter in all the methods. Like, things you want to do with the class as a whole, you can imagine doing meta classes. But it's a bit of a tangent. Okay, so right, back to the main event. So the reason I get to the tangent is it's sort of unsatisfying answer of how does the class object get created. It's created by someone calling a meta class function. But don't worry about for the assignment or whatever, don't worry about like going in and finding what a meta class is. Like that's just gonna get you to more confusion. But that would be a cool thing to do for a project. Okay, so after the build class returns, it just gives you a class object. So that's not super interesting. So what is the class object? The class object, if you look at include class object.h, again, it's just a H and a C file pair. There are actually two things here, struct here. So this is back to your question of in C or C++, you have to define all the fields up front, right? Like these are the fields. There's no more, right? You can't add them or subtract them. But in Python, you don't have to. You can just declare whatever you want. So this thing declares a Py class object and also declares a Py instance object, and that they correspond to what you think it does, right? A Py class object is the class. Py instance object is each instance of the class. So that corresponds roughly to this, right? So a Py class object, this thing is a Py class object, and this thing is a Py instance object inside the interpreter. I want everyone to make sure that they know those are very different things. So what does the Py class object have? The Py class object has it has a head. Like all objects have heads because they inherit from Py objects. So the instance has a head too, just so you can use a Py object pointer on it. This is like a pretty fundamental thing. Every single object you use has its head. And then there's just, it's just self-explanatory. This is a tuple of base classes, a dictionary, some name, which is a string. These are functions or null. So these are weak reference. Okay, so these are more bookkeeping. So I wouldn't worry about these right now. So unsurprisingly, these are the three things you pass into making the class, right? You pass in a name, you pass in a dictionary of methods, and you pass in a tuple of base classes. And they're just stored in there. So that's not super surprising. It's just these three things. There's my dictionary, there's my name, and there's no base classes. It's just there. So what is an instance? An instance has a reference to its own class. So this is a Py class. Every instance has a pointer to the class it was defined with, which makes sense. So you can actually look up the methods, right? Because the methods aren't stored in an instance, they are stored in the class itself. So that's actually pretty important, because if you look here, this instance doesn't have it or next or any methods on it. It has to look into its class. So this actually has a pointer to this thing. I didn't draw it explicitly, but it actually has a pointer. So if you want to call c.next, for example, there's no next here, but you look up into its class, there's a next here. And you pass in the instance self as the self. All right, so the instance doesn't keep the methods, the class does. So that's why the instance needs to keep a pointer to its own class. So now if we actually, go back here. If we actually create two of them, let me just go back and create a second one. D equals counter team. Create a second one. If we create a second one, these are separate instance objects, Py instance objects, but they point to the same class, right? So the really important thing is if I call c.next and I call d.next, they don't affect each other, because even though I'm both using the next function, the next thing, the self here when I call the first time is the c, and the self here is a d the second time. That's why there's a self. They're completely different selves. This is standard, again, object-oriented programming that you see in Java, C, or so forth. It's the exact same concept. The only difference, like you mentioned, is that the instance dictionaries are dictionaries. They're not fixed. Okay, so the instance object has the class itself, the pointer to the class. I think this thing is stuck again. The pointer to the class, and then the dictionary. This is the dictionary that's in the instance. So this is all the fields in the instance is in in_dict. All the fields are in there. So with that, let me fix my pen. Battery seems to be dying. Now let's actually look at the code. So we have the H files, which is the data structure definitions. Let's actually dive into the code. Let me make sure there's nothing else in this file. Oops. These are methods. Yeah, so this is actually good too. We should go over this as well. So a method is simply a function defined inside of a class, right? So a method has the function itself, which is the actual code of the function. It has self, which is a special instance, right? It's a special self parameter, and then it has the class it was defined in. The weak reference thing is just for bookkeeping and stuff. But essentially, what a method is that it's a function with some self and with some class. So imagine in our picture, these things are methods. There is a self thing, which when you call it, it will be one of these things. And then there's a class it belongs to, which is that. So all of this class instance stuff is just bookkeeping. It's nothing fancy. And all these things you should have learned now, because they're all just special Py objects. There's especially dicts, right? These are just dictionary objects. So Python just uses, the interesting thing about Python is it just uses its own built-in objects to represent all these stuff inside. So with that, actually, let's switch into the interpreter a bit. So I'm going to go back into Python land. I'm going to type Python. I'm going to import count. If you made a file called count.py, this should work. So what does import count gives you? It gives us access to count.counter. So we need to say count because this is inside of a file. So we have to say count.counter, not just counter, because it doesn't know what counter is, because you got it inside the file count.py. So count.counter is the class. So that's a class object itself. Let's say type count.counter. It's a type class object. I create a C equals counter. Sorry, count.counter. 57. So the type C is an instance, and the type of C is an instance. So notice how C is a counter instance, whereas counter is just a class, right? And this thing is a class, and this thing is an instance. So they're different types of stuff. So again, we can just look inside their dictionary. So we use dir to look inside something. So it's dir count.counter. I'm going to clear the screen. You notice what's inside, it's actually just the dictionary. Sorry, it's just a bunch of fields. There's init, iter, next. These module and doc things are just built in. That's built into every class you define. But yeah, it's just pretty much this, right? It's just init, iter, next. And if we look at dir C, it's interesting that it actually has current, high, and it actually has the it actually has these things inside. So I think you can access them directly, but it'll actually look up in the counter thing. So if I see, I think there's some hidden ones. I'm just gonna guess. Yeah, actually this works. So if you do the __ dict, that's the dictionary that's underneath, that's implementing this stuff. So count, current, and high is 57, which is this. This looks like a dictionary, because it is. So what we can do is we can modify it. So let's say C current equals 1000. C dot __ dict will change, right? Let's see if we can actually modify it through the dictionary. Yep, you can change it. It's just a dictionary, so you can just modify it as though it's a dictionary. So everything's a dictionary. It's very flexible. There's no type checking, right? You can just do whatever you want with it. You can assign it to anything. You can even do this, which makes a circular reference. It's actually a circular reference to itself. I don't know why you do that, but you can do that. So now if you actually access C dot high, it's actually C itself, which is weird and bizarre. See if we can actually do this in the browser. Again, all these things I don't know why you ever want to do, but you can do them. No one is preventing from doing them. So d dot high equals C. No idea why in the world people would do this, but yep. So C high is the number 7. And C high is here. It just points back to itself. Just infinitely goes. Counter. Oh, sorry. Class count.counter is a class. Let's look at its dictionary inside. Its dictionary has a lot of stuff inside, but most notably, it's the most salient things are iter, which is a function, iter, init, which is a function, and next, which is a function. So the dictionary for the class doesn't have all the instance fields. It has all of these, right? It has these three things. Okay, so it's just, basically I'm just showing you there's all these ways to access the exact same information, that you can access it in the Python interpreter itself. So if you're going to do your project in Python, you can actually manipulate these classes and objects pretty freely just in Python. So we'll talk about the project after the first half of the term is over, but if some of you are kind of scared by, wow, there's a lot of C code and I don't want to modify it for the project, you don't need to actually modify the C code of your project. You can if you want. That's perfectly legitimate to do, but you can actually do your project just in Python, because Python actually gives you all these hooks to manipulate a lot of the innards of the interpreter. So you can actually do really powerful analysis and just kind of weird stuff. So part of the project is if you do something really innovative with Python, you can change the semantics somehow. That's fair game as well. Okay, so then there's methods. All right, so now we'll finally spend the next 25 minutes, we'll actually head into objects. So class object.hc. So it's objects class object.c. So all this stuff is pretty boilerplate. It's just pi class new is a constructor, and it has bases, dict, name. There's so much duplication, as you can see, right? Because we went from the interpreter build class to this class object build class. None of this code is super interesting. It just basically binds the name and dict and bases and returns you a new object. There's a lot of error checking, as you see, right? If you pass in some wrong thing as a name, it errors and errors and errors, and just a lot of boring code for error checking. And it, at the very end, it returns you a class object. These are all just accessors. This pi method function it gets the function out of the method thing, because remember a method, a method is basically a function wrapped in something, because you want to wrap it to show you where the self is. So a lot of this is bookkeeping. Method self, this is getting self out of method. Method class, getting class out of method. Notice how this looks very much like object-oriented code, right? We're actually trying to get things out of particular object. It's just that C doesn't have object-oriented features. It's implemented in C. So the interpreter has to write all these functions that basically are very object-oriented in nature. So class new, it makes a class. Class lookup, class getAttr. And then there should be instance new as well. Okay, good. So let's actually go into this. So remember how everything has a type, right? Everything has a type object. We saw last time we had iterators had a type object. Everything has a type object. So when you actually do stuff to it, it actually finds the right function in this type object corresponding to the right thing to do, and then it does it. So call is what happens when you actually call something as a function. So if we go back, now let's actually focus on this line of code. So we've done this, which is just defining a class, which is a bunch of code. Now let's focus on line 16, which the bytecode just says, push these two parameters on the stack and just call a function. It doesn't have an opcode that says build a instantiate an instance. It's just call a function. So here it just says, recall the bytecode, and one more time, is load the name, take 5 and 7, and just call the function. And all a call function does is pop all the parameters off, pop this, grab this value, pop it off, and then call this on all this stuff. Okay, so in our C val loop, call function. So you did this before when we actually traced the function call, right? Like in the second class or whatever. So it's the exact same bytecode. We don't do TSC. So there's a big indirect thing around it, right? Like we go and call function, which takes the stack pointer and all the opcode arguments. This goes to call function, and then this unpacks the arguments from the stack. This is a C function. I forgot where we went in. We went in PyC function, PyMethod. No, it's not a method. It's a function. Yeah, let's do fast function. Yep, go in fast function. No argument tuple. And then we go to locals, PyVal. You just evaluate the code in the function. So now where is TP call? So I'm gonna find this TP call here. So what you need, I'm gonna go and abstract. That's the abstract. Okay, good. So when you actually call function in CVal, okay, so actually this is, sorry, I'm going to jump around a little bit. Do call, and this is, X do call now. This is call trace. Okay, so do call is actually what we want. So, call object with keyword. Okay, well, however we get here, we get to PyObjectCall, which is just that we have some object and we're just calling it as a function. I think we get here this way. So what does that mean? That means in abstract.c, it just goes to the generic object interface. It just knows that this thing is, oh, that's right. The reason why it does this is because when it looks up to call the function, this thing is not a function object. This thing is a class object, right? This thing is some other object, it's not a function. So it shouldn't just directly call it as a function. It should try to do something special to it. And the special thing it does to it is that it runs PyObjectCall, because it doesn't know what kind of object it is. It just knows it's not a regular function. So we need to go into the abstract.c to delegate to PyObjectCall. So this is a callable thing. All it knows is a callable thing. In PyObjectCall, if there is a TP call field here, which there is, we're actually going to run the call. So what this does is that in C syntax, it checks to see if there's TP call, it assigns it to call, and then it checks whether call is not null. If it's not null, we actually just dereference call and call it as a function. So this basically grabs TP call from your object and then assigns it to a local variable for convenience, and then we just call it as a function. So in our case, because we have a class object, this instance type, sorry, class type. Sorry, I'm gonna go around right here. So our class object has a type called class type. Then we're gonna look inside this dictionary here, or this struct. There's a TP call field here. It's not null, it's this instance new. So this thing is gonna be loaded into the call, local variable here. This pi instance new is going to be here. It's going to be loaded into call. And then we're going to go down here. We're actually going to call it. We're going to call it this function with all these arguments. And we're going to get the result, and we're just going to return the result. And in our case, the result is a new instance that's been instantiated. So in our case, the result is basically calling a init and making a new instance. So let me go back to here. Okay, so then the question is, what is this thing? It's pi instance. So just reading it, it seems like this is a method to create a new instance of the class. Or sorry, it's a function to create a new instance class. So let's jump into it. So when we call counter 57 as a function, we actually end up in a roundabout way. We want to end up in this code somewhere in init. So we want to see how it ends up there. So we have now ended up in pi instance new. The class is the class counter, and these are the arguments for that we pass in, which is what, 5 and 7? Is that right? Arguments of 5 and 7. So we have 5 and 7 with us, and we're here. So let's look in this function in detail. What does it do? It tries to look for init. Aha. Tries to look for the init method in the class. Hopes that there is one. This intern from string is just an optimization of just give me the init string. Now we actually create, a new instance object from the class. So this pi instance new raw, I assume, just creates a new instance object. It tries to get the attribute underscore init from it. And if it found it, these are null. If it found it, it calls init right here. Right? It just calls init on the new thing, and it just returns the instance. So result init. Yep. So it just calls init. It creates an instance and calls init on it. Now where is, one second. The call needs to have inst in it because it needs to know which instance it is. So where do we get that? Set string. This is init equals null. Okay, so a bit confused because this call I thought needed to know what inst was, right? Because when you create it, you need to actually be access to something. I swear I saw it in here when I was preparing, but let me try to see. So again, what this function does is that it gets the init attribute from the instance, which is underscore init. So it looks it up in the instance. The instance doesn't have it, but the class itself does. So it just finds it in this class. And I need to call init with the instance as the self. So I'm trying to find where that actually happens. It happens where, okay, I'm just going to jump around a little bit. Get attribute 2. Class. Let's see. Call object with keywords. Arg. Does anyone see where this is coming from? I'm confused here. High dec init. Inst. High dec inst. High dec inst. Oh. Oh, I see. It actually makes a new instance. Okay. I think it just had this inst just to. No, that doesn't make any sense. Huh. No, because it returns inst. So it creates inst up here, right? That's a new instance that has nothing in it yet because it hasn't been initialized. This is no. I'm just gonna start deleting code, so that's just to not confuse myself. So this we don't execute. We'll delete. We'll delete. So else we execute. If res is null, we delete this. If it's not pi none, decref inst. It should return none. Okay, no. It should return none. That's it. So this is what should execute if there's no bugs. So I'm just going to, basically what I'm doing is I'm just cutting out all the errors in the code so that we just see, this is useful for you to, I mean, when you do your assignment, you should keep all the original code, but when you're debugging it, it's actually really useful to say, assuming there's no errors, what happens? So by rewriting it, it's actually useful. That happens. Init inst. Okay, so init is inst. Oh, does this get attribute have instance inside of it? Okay, let me look at get inst attribute too. I've been seeing this in a while. So inst get item. No, it doesn't. Huh. That's very mysterious.
What's the question?
So the confusion is that this call object needs to know about inst somehow because it needs to modify it, right? Maybe I'm being confused.
Isn't that get attribute?
Get attribute modifies it?
No, like
This one.
like it knows where like the class is. Right?
It knows where inst is. Inst is the instance of the class, right?
Right. But kind of there is a class lookup inside the get attributes, right?
Right. So let's look at get attribute too. Right. There's inst. There's class. Get item inst
It has a
indict.
class lookup.
Okay, so we basically find it in here, in indict, and this gets you the init function. Oh,
It looks up the
oh, I know,
so
I know.
it returns the VI.
Because the it's a method object, so the method actually, see, the method here, I think this is why, the method actually keeps track of what the self is, I think, so it knows what itself is. So this is actually, and it's actually a method object that knows where itself is. Because right now, if you stare at this code, it doesn't make sense because when you, sorry, I totally screwed up this code. But in my screwed up version, this is a function call to init, but it doesn't use inst anywhere, right? It doesn't use inst, and we're actually creating a new inst, and we're hoping that by this constructor, this actually modifies inst, and then we return it to the caller. Right, but I think what's happening is init is a method, and the method has a pointer to inst, so it can modify itself. Does that make sense? So I think that's the case, but I'm just confused. I want to find in the code first before I commit myself. Ideas back there? Yeah, this is a bit confusing, but regardless on your assignment, you don't need to go into this much excruciating detail in classes. So don't worry about this excruciating detail. I just need to figure this out for myself. I'm pretty sure that init is a method object that method new self. Yeah. That's unbound. Yeah. So you create a method new, it actually is bound. Okay. So it's because it's a method object. And so I'm going to gloss over all this. So in short, what happens is we create a new instance and and then we assign it to C. So that's pretty much the whole thing in terms of classes and instances. That classes have this meta class thing that creates them, and then you use a class, you call it as a function, and then that actually goes into what? Let me just recap again, so we can at the right level of detail. So this goes into call function, which is just a regular call function opcode. Call function, and then this eventually goes into PyObject call, because let's actually get to the real one. Call object with keywords. No, there's a lot of jumping around there. It is here. Do call. So do call. Oh, here we go. Oh, actually, we're almost there. So remember, this thing is it's one of these things when you call a function. It's a call function, unhelpfully named. And if we go down here, we're down here. If it's an actual function, we're just going to call it with fast function. If it's not a function object, which is not, this is a class object, we call do call. This is the most generic thing for do call. And then in do call, we have PyObject call. And PyObject call, any PyObject generic thing goes into abstract.c, object abstract.c, and then we have PyObject call. PyObject, names are confusing. And then the most important thing in PyObject call is that we look up this OB type TP call. We look up the type and the TP call thing, assign it to call, and then just call it. And that was in objects, class object.c, TP call. So the TP call method of a class type is PyInstance new, and PyInstance new will do the thing to create a new instance. And the only remaining mystery to this is what the init method is. And an init method is an actual method. So I'm going to disassemble a little bit more stuff. So I'm going to go Python import count, import dis.disCount.counter. I'm going to rip inside the counter class. So notice how when we did a disassembly, we just assembled outside. We're now this dis.disCount.counter will actually disassemble the code inside the counter. So if you notice here, whoa, sorry, there's a lot of code. This is the disassembly of init, and iter, and next. And there's a bunch of magic that happens that makes these into not just ordinary functions, but into actual methods. And the thing with methods that differentiate them from regular functions is that they have a, getting my thing mixed up. They have, this is all in class object.h. They have a reference to a self thing. That's the thing that differentiates methods. So method is just a wrapper around function with a self and a class to give it so that you can access both the instance, because self is the instance of the class it belongs to, class is the class of the class it belongs to. So you might want to actually access fields in the class or the fields in the instance. You can do either with the method. So actually let's go to our code and see that. So if we go to Python import count, if we say count.counter.next, this is an unbound method. It's good. This is a good term. It's an unbound method because it's actually a method, but it hasn't been bound to a particular instance yet. If I say what, actually, can I go inside it? Can I say what this is? Next is a method, right? Yeah, IAmFunc. Okay, good. So IAmFunc is the function, the code for the function. So recall this is good. So this is actually include, like a minute left, class object.h. IAmFunc is here. So they all just correspond. So Python actually exposes a lot of this for you. So IAmFunc, IAmSelf, and IAmClass. Remember those three names? And we have IAmFunc, which is the function. IAmClass, which is a class. What was the last one? Self. There's nothing in IAmSelf. It's been unbound, right? It hasn't been bound to self. But if I say C equals counter, 57, count.counter, B equals count.counter, 15. Okay, so now recall counter.next is a method. It's unbound. C.counter.next. C.next, sorry. Just a dramatic effect. Let me do that. C.next is a bound method now, right? And D.next is a bound method. So that's the exact same method, but it's actually been bound now. So if I say C.next.imSelf, that's C. And D.next.imSelf is D. So notice how these are actually different objects. And if I say count, what is it? Count.counter.next.imSelf, it'll say nothing. So if we say C.next.imSelf equals C, that should be true. D equals D, that should be true, and it should not be C, right? So that every method actually has a self on it. So that's why when you call the init, actually, can we say init here? Oops. Yep. If we call init, oops, it should tell you where it's bound to, and this has no. It's unbound again. So I think that's the mystery that I wanted to resolve. That I didn't see it in the code, but it's in the method itself. So the method keeps track of all the self stuff. So